All right, so for question number 18, we have a football player attempts to kick a football over a goalpost. We have the path of the football can be modeled by the following function of h of x is equal to negative 1 over 225 x squared. And we have 1 over 225 x squared plus 2/3 x, where x is the horizontal distance from the kick, and we have h of x is the height of the football above the ground when both are measured in feet. It says given the set of axes below, we want you to graph this over this interval, over x being between 0 to 150. So if I go to my calculator, now I'm doing this from my calculator app on my phone, I'm going to go to y equals, and I already have my equation typed in. Make sure you have this typed in correctly. And I'm going to do zoom 6. So if I do zoom 6, see what happens. That's my equation. That's my graph. But now I'm supposed to be graphing a parabola. Parabolas are of degree 2. That to me looks like a line. Well, the question said we want it over this interval from 0 to 150. So let's try this. We have to go to the window. So I'm going to go to my window. I want x min to be 0, and I want x max to be 150. Now think of this. I'm kicking a football. Can this football start from below the ground? I hope not. So I'm going to bring y min down to 0, and now I'm going to graph this. Now if I look at my graph, I don't see the tippy top. I'm not seeing the entire graph here. So I'm going to go back to the window, and I'm going to bring y max to maybe about 20. Let's see what happens. All right, so I'll bring it up to 20. All right, that's still not enough. So I'm going to go back to the window, and I'm going to make y max go up to 30. Hopefully that does it. Yep, that's enough. So now I can see the full path of this football that's being kicked. So now I can actually start to graph this. Now, here's a trick that I'm going to show you guys. If I do the following, second window, I'm going to change table start to 0, and I'm going to change delta table to 10. So let me show you how to do this. If I go to second window, so let's do second window, I have table start at 0, and I'm changing delta table to 10. So now, when I go to my table, if I do second table, it starts off at 0, and I'm going by tens. Now the reason why I chose this is because look at the increments we're given. Look at the number of boxes. I want to graph this from 0 to 150. So I counted every 2 boxes to go by 10. So I did every 2 boxes is going by tens up until I got to 150. On the y-axis, I went every 2 boxes by 2s. So I went 2, 4, 6, 8, 10, 12, etc., all the way up to 28. So all I did was just using my table of values. So if I use my table of values, I can just start graphing these points. So I have 0, 0, right? That's where it's starting from being kicked. I've got 10, 6.22. So you want to roughly approximate these. I've got a point at 30, 16, and this is going to go all the way until it falls back to the ground. This is going to fall back to the ground after 150 feet on the horizontal axis. It's going to hit the ground. All right, so after plotting all these points, your graph should look like this. Now, the first part says determine the vertex and interpret the meaning of the vertex in the context of the problem. So I need to figure out what the vertex is from this graph. So let's go back to our graph. If I do second trace, notice that this was a maximum. This ball was being kicked in the air. I'm going to click enter. See how it says left bound? I want to go left of the maximum. Sure, that looks good enough. Click enter. I'm going to go right of the maximum. That looks good enough. I'm going to click enter. And then I'm going to bring it all the way over to where I think the maximum point actually is, which may be right about there, and then click enter. And it's just loading, and we've got 74.99999, and then y is 25. Now guys, when you have something like this, that means that x is just, your calculator hasn't rounded it all the way. This is really 75, and then this is actually 25, so this is all good. So I have, this is 75, and then this is 25. Alright, so what I was saying before is that 75 is our x value, and our y value is 25. Now that is for our vertex. So to answer this question, it says, state the meeting. Well, we know that the x values was mentioned up here is the horizontal distance from the kick. So I know at 75 feet from the horizontal distance of the kick, it ends up reaching a maximum height of 25. So that's what I ended up writing over here. The vertex is a maximum. It is the highest point where the football is above the ground at a horizontal distance of 75 feet. The ball is at a height of 25 feet. All right, so the next part says, the goal post is 10 feet high and 45 yards away. Now, you want to be careful here. Here I have feet, and here I have yards, 2 different units. You need to know that 3 feet is in a yard. Okay, so we're trying to find out, will the ball be high enough to pass over the goalpost? And the answer to that is no, because if we look at this, guys, I'm at 45 yards away. 45 yards away is going to end up being 135 feet because I have 3 feet is in a yard, and 45 times 3 is 135. So when I multiply those, I have 45 times 3 is 135 feet away. So if I look over here at 135 feet, that's about here. It's actually, the ball hits at the point 9 at 9 feet, but the goalpost is here at 10 feet. So it's actually going to hit right into the goalpost. So again, the goalpost is 10 feet high. And if we actually even check on our calculator, so if I go back and check on my calculator and I go to the table, if I check out when we have 135 feet, so let me just adjust my window here. I'm going to start this at 135 feet. When I go to the table, my y value is at 9. Okay, so because my y value is at 9, it's going to hit the goalpost and it's not going to make it past. Alright, I hope this video was helpful. My answer key is posted again online as well. Best of luck as you study for your test tomorrow. Alright, have a good night. Bye-bye.